You might be expecting a PRISM as a service, not subject to American law, which I'm still giving. I just added more, and it's prettier, and it's going to be more fun. So, so the new title of this, same content, more stuff, How to Spy with Python, so easy the NSA can do it. So I am, let's see, does this even work? Sorry. There we go. So I'm Lynn Root, Rogue Lynn on the interwebs, and this presentation you can find at rogue.ly/spy. And yeah, that is my real last name. I guess I'll start off with a tiny little joke. I've never done jokes before, but my father, he's a software engineer. He graduated high school, went straight into the Air Force, and he was doing like computer sciencey stuff in the Air Force, and they're like, oh, look, you're already in the system. We don't have to give you a username. So they let him run with root. All right, so who am I? I work for Spotify. I'm what's called a partner engineer. It's kind of like a back-end engineer meets like a developer advocate meets like just integrating with third-party partners to like use our apps and stuff. A lot of API building and API like systems running. Mostly Python, some Java. I run the PyLadies of San Francisco. It's actually, PyLadies started out here in LA about 3 years ago or so. Wow, it's so long. And PyLadies of San Francisco has been around about 2.5 years. So it's really fun. It's for women in Python, but it's for everyone, but we promote women. And I'm also on the board of the Python Software Foundation. So I'm kind of all about Python, if you haven't noticed. So the obligatory disclaimer that I must say, I am not affiliated with the NSA, FBI, CIA, or anything like that, any alphabet soup. I am not a lawyer, nor am I a black or white hat. And this is just a proof of concept. There's no warranty, no promises, no anything. So my talk today, I'm going to go over historical context of kind of what the NSA has done before and bring us up to the now, what they're doing right now with PRISM and with X-keyscore. That leads us to a lot of unanswered questions that I'm sure a lot of you folks have. And then how you can do it, because it's fun and it's easy. All right, so what this talk is not. It is not condoning what the NSA is doing. It is not how to avoid being tracked by the NSA. It's not encouraging you how to spy on your friends or family or anywhere where there's free Wi-Fi. All right, so we'll start off with the historical context. The TLDR, basically what the NSA is doing with PRISM is nothing new. So starting in actually 1946, we have the Five Eyes group. You might be familiar. It was comprised of USA, the UK, Australia, Canada, and New Zealand. They share intelligence, especially signal intelligence. And each country would surveil a set of countries, like the US would focus on Latin America and share it with Canada. But there's no sort of law against or rule against Canada spying on the US and sharing the data with the US. I'm sure, I mean, they say that we don't spy on our own citizens, but you can still get around it. And so what, next thing, in 1952, the NSA was established. Originally, it started in 1917, right after the US declared war on Germany. It morphed into the Armed Forces Security Agency after World War II. And then sort of the AFSA couldn't really get its shit together, so it's restarted or rebranded itself with the NSA in 1952. Over 20 years after the NSA was formally established and after 50 years of starting US surveillance, the Supreme Court finally required warrants for domestic surveillance. In 1978, 5 years afterwards, the Senate's Church Committee revealed illegal domestic spying by the NSA in 1975, with the Foreign Intelligence Surveillance Act being signed into law. There was also the secret court that was established, the Foreign Intelligence Surveillance Court, and was created for the purpose of hearing those warrant requests that were required. In 2001, after 9/11, there was a culture shift, at least publicly with the NSA. Perhaps privately, they're always for domestic spying, but at least publicly, they're more towards it. So within the first month after September 11th, the White House asks the NSA what more could be done against terrorism if it had more power. The NSA resurfaces a plan originally deemed illegal in 1999 to collect or contact to chain contact data with metadata. Sorry, and the U.S. president gives authority for the NSA to do just that and to begin targeting the terrorist-associated foreign phone numbers. Still within that first month, the U.S. president and the cabinet sort of scrambled together because they realized that there was domestic spying going on, but it wasn't legal yet, and so they had to create an authorization to do that. So the Bush signs that order to allow domestic spying, and now the NSA feels that it's allowed to spy on U.S. calls and emails. Now, of course, the U.S. Attorney General was just told to just sign it, just go ahead and sign it without even reading it, and the General Counsel of the NSA deems it legal. Shortly after, unrevealed telecoms and internet providers in the U.S. received letters from the NSA requesting data and support for its domestic spying program. And then one AT&T employee discovers the NSA working inside of its San Francisco facilities. And then now telecoms formally enter into a voluntary agreement with U.S. to give data to the NSA. Voluntary. And then there's this installation of special technology in a super secret room number 641A at AT&T's SF facility. And it was to read and analyze tens of thousands of communications per second and then send that communications to a central database. 2003, we have the Total Information Awareness. The program started in 2003, but it started actually being developed in 2000. And it's aimed to gather detailed information about individuals to anticipate and prevent crimes. And they do a lot of data sharing within the FBI and CIA as well. Congress stops it supposedly, but then it just kind of quietly moves under the NSA's domestic spying program. All right, so 2005, the New York Times reveals that the NSA has been spying on Americans without warrants, and soon after, Bush confirms the warrantless eavesdropping. The New York Times also reveals that some of the NSA's spying is purely domestic, with some telecoms giving backdoor access to communication streams. And soon after, New York Times articles, an unknown company requested the NSA to issue court orders rather than companies voluntarily giving data. So only after that they were publicly released did telecoms go in the reactionary and say, now you need a warrant. 2007, the Protect America Act was passed, allowed the NSA to not need those warrants for collecting communication. All right, so then September 2007, data collection for PRISM starts with Microsoft. 2008, U.S. Congress passed amendments to the FISA that gives telecoms immunity, legal immunity for those that cooperated with NSA. 2012, the NSA now starts to build its biggest spy center in Utah for the collection and intercepted data. In 2012, the FBI also pushes for wiretap-ready websites, asking internet companies to not oppose a law making backdoors mandatory. 2013, we all remember that the Washington Post exposes the PRISM program, and then shortly after, the X-Keyscore program was revealed. Okay, so then now we're at the now. What exactly is the NSA doing? First off, what is PRISM? PRISM stands for Planning Tool for Resource Integration, Synchronization, and Management. It's a mouthful of words that we don't really know, we don't really understand when all put together. So what it does is it mines electronic data for the purpose of mass surveillance, collects intelligence that passes through the U.S. servers, and I'm sure you know that a lot of the internet traffic passes through the U.S. even if it's just purely in Europe. It targets foreigners, but it's very elusive about the data that it gets or accidentally gets on U.S. citizens, and it supposedly only collects metadata. Now, what is X-Keyscore? It's a digital network intelligence exploitation system, another mouthful word. It's a federated query system of completely unfiltered data. As of 2008, I only had up to about 700 servers, which isn't a lot, but as I mentioned earlier, 2012, they built that big spy center in Utah, so I'm sure they have tons more. And it gives the NSA users the ability to query for email addresses, a target's activity, phone numbers, HTTP traffic, extract file attachments, etc. All right, and so that leaves us with some unanswered questions. All of this is public knowledge. All of this was revealed in newspapers, and the EFF does a really good job chaining everything together. But now, where does that leave us? So what does metadata actually mean? And how do companies not notice being ignored, or are they just lying when denying cooperation? And how is the target's foreignness determined? How exactly are they identifying non-US citizens? And what is done with data that accidentally is collected on Americans? How is PRISM collected data handled by the NSA? Does the NSA maintain rigorous security measures to protect against threats? So can they have my data by accident? Can someone else get it through some other secret door that the NSA is not aware of? And so this next slide, the few bullet points are taken from the EFF's presentation at 33C in Berlin this past month. And it's about why metadata matters and what it is. So they know you rang a sex phone service at 2:24 a.m. and spoke for 18 minutes, but they don't know what you talked about. They know that you called the suicide prevention hotline from the Golden Gate Bridge, but they don't know but the topic of the call remains secret. They know you spoke with an HIV testing service, then your doctor, then your health insurance company in the same hour, but they don't know what was discussed. So that's just to illustrate how important metadata is. They might not know the actual content of the conversation, but they can glean a lot of information just from metadata. All right, now kind of how the NSA is doing it, presumably. So it's through the tier one, the backbone of the internet. The tier one internet allows vast swaths of data to flow from one endpoint to another in the simplest path versus consumer internet, which hops looking for the cheapest path. Major companies like Google, Facebook, etc., are able to tap in the tier one network through entry points called edges. And then rather than walking into Google or Facebook's data centers and be noticed, the NSA actually just wiretaps these edges between major companies and the tier one network. And you might be asking, what about a TLS SSL encryption? Well, who's to say that they're not just calling up certificate authorities and getting access to private keys, or trying to decrypt it themselves? So it's actually probably like this. I don't know if you can see that, but in the first comic, it's saying we're going to build this big machine to try and decrypt a 4096-bit RSA key. And what actually happens is just brute force of knocking someone over and trying to get the password out of them. So NSA has a lot of power. So the point is that they have the data. How they got the data, it doesn't really matter anymore. Okay. So now comes the fun part. I scared you all by what the NSA is doing, what they can do, and now it's how you can do it. I should have brought my little mask and stuff, but we're supposed to, be a hacker, right? And that's how the media thinks a hacker looks like. So if you happen to have one of those things, maybe you can borrow it for the rest of the presentation. Yeah. Anyways, so, tools used. This is IPython. This whole presentation is written in IPython, and it's rendered with reveal.js. I use Scapy for packet sniffing and manipulation. PyGeoIP, which is an API for GeoIP databases. Then GeoJSON, bindings and utilities for GeoJSON. And then last but not least, Python Nmap. It's a wrapper around Nmap port scanner. And if you want to play along, if you happen to have a computer or anything, this presentation is just at rogue.ly/spy. But then the complete notebook is spy-notebook. And then I do a quick introduction to Scapy. And then all the queries, the individual queries, are spy-number of query. And then the whole repository of the notebooks can be found at just /spy-repo. Really, you only need this first link because then you can find the links associated with that. All right, all the fun stuff. A quick introduction to Scapy. And so if you're a Pythonista, you are cringing at this because import star just is really bad, like programming technique, I guess. But to get started with Scapy, you import from star, and this is how you sniff. It's just you specify the interface that you want to sniff on. You filter for TCP data over port 80, so just TCP, HTTP traffic. And we're only limiting to 10 packets. And so I'm sniffing, and I got 10 packets. You can see 10 TCP packets right there. And if I look at what it gave me, it's pretty much a barf of information. You can't really make sense of it all. It's just too much. So if we just look into the first packet, it's a little bit more bite-sized for us. And then if we use Scapy's .show function, it's actually a little bit prettier. So you can see that the Ethernet layer, the IP layer, and then scrolling down the TCP layer. All right, so that was all that we're really going to use with Scapy. It's actually really simple. So the following queries I'm going to go over, these are actually queries that were presented to NSA employees before this presentation got exposed by Washington Post. So the language of the queries are exactly from their own presentation. I just prettied up the slides because the NSA does not know how to use like Keynote or something like that. And these queries they're just a proof of concept. We're not like storing any data unlike the NSA. And once again, I'm not condoning you to spy on your friends or family or anywhere where there's free Wi-Fi. All right, so the first query, show me everyone that has searched for a Y term. So we're gonna, I have a PCAP file from earlier, and I'm gonna use Scapy's offline capabilities of sniffing. You can also just sniff actively and then save it for later. Notice that I'm using Yahoo rather than Google, because Google now encrypts all of its traffic over HTTPS, and Yahoo does not. I'm limiting to 300 packets. So if you look at what the packets give us, I still have 300 TCP packets. And if we get a summary of it, we can just get pretty much a dump of everything. So the first one goes from Ether to IP to TCP, from IP, from that destination port to the IP, from and then to the IP, and you can see the SYN and SYNAX and the raw flags. If we just pick one packet in particular, I'm picking number 79, and we get that pretty little packet printing. If we scroll down a little bit, you can see what's actually kind of gets interesting for us is the raw load of the packet. I'll go into that a little bit better, but you can kind of see like maybe some headers, the HTTP, the host headers, let's see, stuff that looks familiar to us, the user agent. You can see the GET request of the actual URL. Scapy is just so much fun. So the next one, if we just wanted to get the raw layer, we get that part. Now we got to parse it a little bit. I know that all Yahoo's queries are right after $P equals, so I'm just parsing that out. And anything after the ampersand is not what I need. So I can see that my first query was Madrid when I was sniffing traffic. And then the second query was I love chocolate, because I do. And then the third query was blue bottle coffee that I misspelled when I was sniffing my own traffic. So you can see that it's really easy to pick up what you're searching for. Of course, I did it with my own traffic because I don't want to be like nefarious and I don't want to like snoop on other people. But it's extremely easy to do that in open Wi-Fi networks. All right, next query. Show me everyone from X country that has visited Y extremist forum. So importing Scapy again, we're using a PCAP file that I already have. Getting 41 TCP packets, 2 UDP packets, and looks like all. And then we're picking up packet number 3 and get another pretty printed one. You can see some the raw data again. So the raw data looks familiar. And all you basically have to do is is that host name within the search query, or you could actually put that in your sniffer filter itself, just that host. Like, is this person visiting, or is any traffic visiting this particular host? And so, I hope you can see it all. This is just a quick and dirty trace route function of all the IP address hops that it takes to get to the host that I'm targeting. I get all these IP addresses. And quickly, geomapping this, trying to get from IP address to the coordinates, latitude and longitude coordinates. And you can see I have a bunch of tuples there. Now I'm using GeoJSON to create a GeoJSON file. And I get this JSON-looking blob of data. And then if you use GitHub to actually plot, you just throw this up on GitHub and you can actually see all the traffic mapped out. So you can see that probably started, I was in Sweden at this time, so the traffic started in Sweden, ended up I think in Kansas, and then back to the UK or something, and then over to San Francisco, and then at some point got back to me. So that's pretty interesting. So you can actually geoplot the whole movements of where I initiated the request to visit a site and the hops that it took to get there. All right, so on to query number 3. Give me all emails with X in the body of the email. So I have an SMTP PCAP file, just a different filtering. And you can see from the summary, the first line you can see mail.patriots.in. That kind of looks like a mail packet. And then we have SMTP traffic as well as some other flags. Oops, sorry. And then we're going to look at packet number 11. And if we just get the raw, we can see it looks encoded. I just want to get rid of the null characters. So then let's see if we can decode it. And it looks like it was an email address. Now the next packet, I'm curious. This is another encoded string. It happens to be a password prompt. And so the following packet is what do you think it'll be? Password. This was taken from a PCAP file that someone put up online, so he's well aware that his password is out there, and I'm sure he has since changed his password, I'm hoping. But that's easily available. So then I made another little kind of query, so I can see that if this particular email has the word attachment in it. And query found. So you can see the whole email in plain text, even though it was sent with SMTP. And you can see the attachment name in there, or the word in there. And if you kind of scroll a little bit down further, you can actually see the attachment. This is the attachment plain text. So a little bit of packet sniffing can actually pick up the attachment of the email. All right. Now, query number 4. Give me PGP usage from a certain country. I have a PGP email that I was playing around with, and so I'm just opening it up. I'm reading it. And here is the PGP email that you would otherwise see in your mail client. Notice that all the headers are not encrypted. Only the body of the email is, which is here. So you're still able to see who it was from, who it was to, the routes it took, as well as what what version of PGP I'm using, and what client for GPG and PGP. So then you could just do a little, you have to search for this protocol equals application/PGP encrypted, and bam, I am easily able to tell that it was encrypted with PGP. And then so now I want to know where this went, where this came from. So again, I'm plotting all the IP addresses to latitude and longitude. And, it started off in Germany and it kind of bounced around. I was in San Francisco at that time, so you can see that you can see all the hops that it goes. I mean, even though that I was not in I think that's Switzerland or maybe up in the UK, even though I wasn't there, there's still hops there. So if like Switzerland had like a spy on everyone like regime, it could like traffic would still be probably sniffed by them. So this is just to illustrate that a lot of traffic goes everywhere, even if it's just directly between one point and another, and doesn't hit like Switzerland or something like that. All right. So query number 5: show me chats for a certain user during a certain time frame. So I have this IRC Skype cap file, and I have a lot of packets. And then we can see that it goes over port 6667, and we have a free node host name, so this looks like IRC. And doing a little pretty printing sprintf stuff, you can start to see some conversations going on, especially down here. You got some unencrypted ones. There you go. So it's easy to pick up or see plain text chats over IRC. We're doing some filtering because that was a lot of information, and I'm particularly filtering for the user Americ. And you can see sort of the private messages between Americ and Yellowkey at the beginning, so you can see this whole conversation. That's kind of scary, but I mean, what do you expect with IRC? All right, so final one. Find all exploitable machines in Z country. Now, I'm not going to tell you how to exploit or what is exploitable, but I'm going to show you how you can find machines that could be exploitable. So we're using Python's nmap wrapper, and I'm just going to scan Bitbucket over port 22 to 443. And I get this information. You can see that the first line is the actual command line if you're running it in Bash. And then you can see on port 25 that it's an SMTP port. You can also see that on port 53 is bind and that particular version. And then port 80, you can see that Nginx 1.5.3. Now, I'm not aware of any exploitations, like I don't pay attention to that stuff, but if there's an exploitation against like Nginx, you can easily, a particular version, you can easily like, all right, well that's vulnerable, so let me try and exploit that. I know there's a lot of exploits against Apache, and if they didn't update their Apache installation, it'd be really easy to exploit that too. And so I'm just taking this particular host, this IP address. Again, I'm plotting it against JSON, or getting the latitude and longitude and getting the GeoJSON for that latitude and longitude. And it's just one particular like point. You can see that this particular Bitbucket host is, if it zooms out a little bit more, it's near Boulder, oh yeah, there we go, Denver. So this particular host is in Denver. All right, so we went over 6 queries. Now we're going to wrap it up a little bit. So there's a long historical precedence for mass surveillance with very little oversight or restriction, and you can see that this is nothing new that we explored. Safe to assume that the NSA is pretty much spying on everyone, even its own US citizens. Made a quick conjecture of how the NSA is actively backdooring communications. Kind of sort of how to get yourself on the no-fly list, but not really. And how to implement your own sort of toy prism and X keyscore in Python. Now that went a lot quicker than I originally planned, but that is it. And I want to thank you for your attention. I'm here for questions too.